Hello and welcome to Gaffey's Grinds. This is video 1 in our junior cycle series on rates of reaction. In these videos, we take concepts from junior cycle science, we break them down into small, simple pieces, we give you some explanations, and then we give you some practice, enough practice so you guys can master the concepts. Some tips for watching these videos: you definitely should not have your phone beside you or switched on and going off and distracting you. So either put it on do not disturb or put it somewhere where in another room, maybe where it can't distract you. Close any open tabs, especially social media, because again, it's just going to distract you and you're not going to be able to finish watching the video properly. And most importantly, when I ask you to do things, questions, tasks, that kind of thing, it's really important that you do them. Otherwise, it's pretty much wasting your time watching the videos. So we're going to begin today by trying to answer the question, what is rate of reaction? And we're going to begin this by looking at 4 examples. Okay, so the first example I want to talk about is, I want you to imagine that we have a bomb. A bomb basically contains a large amount of explosive chemicals inside some kind of a casing or a housing, usually made of metal, or sometimes be made of other materials, but metal's a good material. And it usually has some kind of a detonator, which is like a little handheld, like remote control that if you push the button, you start the chemical reaction inside and you get what we call an explosion. So the bomb will explode. And when the bomb explodes, it usually releases loads and loads and loads of energy. So this energy is released as usually loads of heat, sound, and light. And it's really, really quick. As soon as you press the button, bang, the bomb goes off. We call this type of reaction an explosion. So this here is an explosion. Another example would be if we were to take a fuel. Fuels are substances with large amounts of energy in their chemical energy store. And we take a fuel and we set it on fire. And it starts to react with oxygen from the air. When it does that, it releases some of the energy inside it as, again, heat and light. Now, only certain substances are good as fuels. Things like coal and wood and gas and peat. These things are very good as fuels because they've got a large amount of energy in their chemical energy stores. And when we decide to burn them, or when we decide to set them on fire, we call this type of reaction a combustion. So anytime we burn a fuel, we've got a combustion. A third example is, I want you to imagine that we have a beaker, and in my beaker, I've got some acid. And this type of acid is called HCl, hydrogen and chlorine, or what we call hydrochloric acid. And what we're going to do is we're going to take a little piece of magnesium metal, and we're going to put the magnesium metal into the acid. So here is my magnesium metal. And when I put it in, it's going to start a reaction, the same as the first two, but it's nowhere near as violent and quick. Okay, so what you might see is you might see some bubbles produced. You might see some bubbles, you might hear some fizzing. So bubbles, fizzing. When you ever hear bubbles or fizzing, that's a good sign that there is a gas being produced. So this is a reaction that's producing a gas, and the gas rises to the surface and evaporates from the surface of the acid. And this here is a type of gas. We call this hydrogen gas, or H2 for short, hydrogen gas. Hydrogen gas is produced during the reaction. This is a reaction between magnesium and hydrochloric acid, HCl, Mg, magnesium plus hydrochloric acid. The last example we're going to look at is, say we have a block of iron. So this here is a block of iron. Now, if I was to leave this iron out, then over time, what's going to happen to it is that some oxygen, O2, from the air is going to react with it. Again, this is much more slow than the other 3 that we've seen. So it's like your bike chain is made of iron. If you leave your bike out in the rain and in the air, so that's telling us the two things that are needed, H2O and oxygen will react with the iron in your chain, and they make a substance called rust. So what happens is the iron begins to rust. So the outside of the iron forms this substance rust with the oxygen from the air. So the outside of the iron turns like a brown color. This is called rusting. All four of these are what we call chemical reactions. So what does that mean? So we have this word reaction. Reaction. Well, a reaction always starts with some materials. So I have these two materials here. Actually, I'm just changing my mind here. I'm going to change the color of those. So I've got two materials that I'm starting with. So for instance, this could be the iron from below. So it's the iron. And I'm adding to it another material. So this could be the oxygen from the air. So this is a different material. I know that because it's a different color and a different shape. And if they're going to react, I'm going to show an arrow to show a reaction is happening. They're going to form something different at the end. So what you see here is the atoms rearrange themselves. Notice that there's no new atoms. They're still all the same atoms, but they have rearranged themselves. So you can see here that what is being formed is completely different. The atoms are in completely different arrangement from what we started with. Now there's no new atoms that weren't there in the beginning. There's still only the green and red one, or the blue and the red ones, but they have got a new order now. So in a chemical reaction, if I was to draw a line down the beginning, or down the middle, sorry, everything on the right and the left of this side are what we begin with. We call these reactants. These are the reactants. So in that case, it would be the iron down here. So the iron here would be the reactant and the oxygen would be the reactant. And then what we form on the other side, the rust, for example, this is going to be called products. So sometimes you get one product, sometimes you get more than one product. So reactants producing products. That is what a reaction is, a chemical reaction. Now, obviously, these are not all the same though. What's different about these reactions? Well, what's different about these reactions is the speed that they happen. So we've got this term rate of reaction. Rate of reaction. That's what we want to know what it means. So this word rate, then we know what reaction means. What does rate mean? Well, rate basically means how fast or how slow. So rate refers to the speed, how fast or how slow does the reaction happen. So obviously, explosion here is the fastest. So it's a very fast reaction, and a combustion is quite a fast reaction. Once you set something on fire, it will continue to react. It doesn't take that much to get a fire started. It's pretty, it's pretty quick. The magnesium and hydrochloric acid is slower, but it's still faster than the rusting. The rusting can take like weeks or months or even years. So for example, rusting is an example of a very slow chemical reaction. Magnesium and hydrochloric acid, it's faster than rusting, but it's a lot slower than burning fuel or lighting a bomb. Those are really, really quick. Those almost happen in an instant. Especially a bomb, you press the button and bang, the whole lot nearly just reacts straight away. So that's a really fast reaction. So rates of reaction tells us that chemical reactions can happen at different speeds. Okay, you ready to do some practice questions now? All right, so what I want you guys to do is I want you to, just before we do the practice, the question, I suppose if we look at what's actually happening down here, that tells us that a chemical reaction is happening. So if remember, we talked about light, sound, heat, all of these are basically types of energy transfers. So if energy is being transferred as like heat or sound or light during a reaction, then that's a good sign that there's a chemical reaction going on. You're forming a new substance and energy changes are happening. So this is a good sign that a chemical reaction is happening. I suppose that's going to apply to both of them, heat, sound, and light. In this one, we have fizzing, which tells us a gas is being produced. Okay, so that tells us a gas is being produced. Again, a good sign that, okay, we definitely didn't start with a gas. We've got magnesium, which is a metal. We've got hydrochloric acid, which is a solution, so it's a liquid. And then all of a sudden, you've got this gas being formed. That wasn't there in the beginning. So obviously, you've got this new substance. It's definitely not the same as what you started with. So that tells you there's definitely a chemical reaction going on. And this one, a color change. We're going from kind of gray color of iron to this dark brown color of the rust. So we've got a color change happening, another piece of evidence that a chemical reaction is occurring. Okay, so these are evidence that chemical reactions are occurring. All right, so back to the questions. All right, so what I need you guys to do is in the first one, you have to select which one you think is the correct answer and write it down. The next two are filling in the blanks. So you write out the full sentence, fill in the words. The next one, you have to say which ones are the reactants. And number 5, explain how you know that they're reactants. Then number 6, you have to write a paragraph to explain why the first statement is incorrect. And then number 7, give 3 pieces of evidence that chemical reaction is occurring. And then number 8, define the rate of reaction. So say what it is. Okay, so pause the video and do those questions now, please. All right, so you should only be watching if you have had a go at doing them questions. It's really important that you do that now. If you haven't already, if you're just going to sit and watch, then you're wasting your time. So make sure you're doing the questions. Okay, so the first one, what does rate mean? Well, the one that makes sense is the first one, how fast or how slow something happens. That is rate. So rate does not mean the ability for something to happen, and it does not mean how much energy a reaction releases. Those are different things. Rate means how fast or how slow or what speed. All right, an explosion then has a something rate of reaction. Well, that would be a fast rate of reaction. You might have said very fast. You might have said high, very high. Those are okay as well. Okay, so if you said something like fast, high, quick, all of those are okay. Rusting then has well, that would be a slow or a low. Okay, so talking about how slow the rate of reaction is, a lower rate, slower, happens more slowly, whatever way you said it there, all of those are okay. The following shows a word equation for a chemical reaction. Hydrogen plus water. Oh, that's wrong, isn't it? Sorry. Hydrogen plus oxygen, that should say. That's my fault. Oxygen, right? So now what I need you guys to do is I need you to pause and I need you to fix what you've written down. Do that now. Okay, so hydrogen plus oxygen gives you water. You have to identify the reactants in this equation. All right, so remember how I showed you how to do this? If you break a line down through the arrow, well, everything on the left of that are the reactants, and on the right are the products. So water is the product, hydrogen and oxygen are the reactants. So that's what you should have said, hydrogen and oxygen. How do you know? So you definitely should have used the word left or before the arrow. Okay, so you should be writing a full sentence. I'm giving you the phrases you should definitely have to include before the arrow. Left of the arrow or before the arrow. Left-hand side, you could say either. Okay, some people think that like all chemical reactions finish in just a few seconds. Write a paragraph to explain why this is wrong. Okay, so I can't tell you exactly what your paragraph should say, but you should definitely refer to some examples. So you could definitely use the example of rusting. Rusting is a reaction that does not happen in just a few seconds. So it said some people think all chemical reactions finish in just a few seconds. So what's wrong? Well, we've learned about rusting. We know that rusting shows us that reactions can take much longer. So if you use the rusting as your example, you can say, this is not true. All reactions do not finish in just a few seconds, because rusting is a chemical reaction that can take up to, a few days to a few weeks, up to a few years. Other chemical reactions can also take quite a long time, but we have rusting as one classic example. There are definitely other materials that will react very slowly. So definitely not all reactions happen in just a few seconds. Even the magnesium and the hydrochloric acid that we used, like you're talking about like at least a minute or two until that reaction is finished. It's not just a few seconds. Okay, give 3 pieces of evidence to tell you a chemical reaction is occurring. All right, so hopefully you're talking about things like light, sound, heat. So if heat is given out or heat is taken in, or you've got light or sound given out, you've got color change, you've got fizzing, all of these are signs that a chemical reaction is taking place. All right, good. If you said, I'm looking for 3 of those, so well done. If you got 3 of them, that's good. Okay, 3 pieces, make sure you got 3. And lastly, define rate of reaction. So make sure you're using the phrases how fast or how slow. All right, now that shouldn't be all that's in your answer. That's just the key part that you should have in it. How fast or how slow a chemical reaction is happening. That's what we mean by rate of reaction. Okay, how fast, how slow chemical reaction is happening. All right, good. Right, let's look now at why we are worried about rate of reaction. Why is it important? Well, rate of reaction is very important in industry. Now, what do I mean by that? Well, if I've got 2 factories, so say here, I've got 2 factories. All right, this is factory A, and this is factory B. This is B, A and B. And the factories, they produce a product. Okay, now, what might that product be? Well, it can be a wide variety of things. It can be cosmetic products that people use, like, you know, foundations or lipsticks or eyeshadows, all those cosmetics. It could be vaccines. So it could be a vaccine for our vaccinations for our COVID-19 that's going on at the moment. It could be what else are we talking about? Could be different foodstuffs. It could be different chemicals that we use as fuels, petrol and diesel. It could be different oils that we might use in like you know, aromatherapy or medicine. It could be many medications would be made in a factory like this. And say the difference between factory A and factory B. So they have 2 owners. You've got the owners here. And the owners, of course, what do they want to do? They want to make money, don't they? Now, they both make the same product. So factories A and B make the same product, but owner A produces at a faster rate of reaction than owner B. Faster rate of reaction, and owner B has a slower rate of reaction. So they produce the same product, but at different rates of reaction, different speeds. Okay, now, you see, the thing is, both owners have the same amount of time to make their product because there's the same amount of time in everybody's day. It doesn't matter where you are in the world, we all have the same amount of time. So they all have the same amount of time. Now, over 12 hours, factory A, so if I take a day and we go over 12 hours of working and producing products, over 12 hours, factory A is going to produce more of the product. The reason is they're working at a faster rate of reaction. So their product, they make more of it. So they have a lot of product. Whereas factory B, they also produce product. It's the same product, but their rate is lower or slower, which means over 12 hours, they produce less product. That means that factory A has more product to sell and therefore is going to make more money. So here comes the euros piling in. All right, so we say factory A has more money made. Whereas factory B has less product to sell. So more product for factory A, and less product for factory B. Now, if factory B has less product to sell, then that means they will have less profit or less money made. This helps us to see why rate of reaction is really, really important in industry. It's very important. Okay, and most people who work in science, in the science field, need to know about this, because whatever they're doing, they need to try and optimize their rate of reaction, make the rate of reaction as high as possible, so that they can either produce enough product to meet customer demand, because customers want their product, and if it runs out, then people are going to be annoyed and they might stop using your product and go to somebody else. But it also means that the business that you work for, or your own business, if you're lucky enough and you're smart enough to go and set one up, that you have more product to sell, you are going to make more money. And that's what business is about. It's about making more money for yourself. So if you have even a small business like making handmade soaps or making handmade cosmetics or something like that, even on your own scale at home, the higher, quicker rate of reaction you can have, the more money you're going to make. It's simple economics. So it's really important in industry. So rate of reaction is important in industry for that particular reason. All right, let's do some more practice. Before we do, I've got here a quick question for you to do before we go to some of the shorter questions. Here it says, below are two statements, A and B. So here are A and B. Okay, A and B. Two statements. Label them as either a cause or an effect. So one of them is cause and one of them is an effect. So I want you to read the two statements carefully, pause the video, write them down, and then label them as cause or effect. So do that now. Pause the video, write them down, label each one as either a cause or effect. Do that now, please. All right. Hopefully, you should have done that. And which one is a cause, which one is effect? So the two statements are slower rate of reaction, less money made. Okay. Well, to me, less money made, this is an effect. This is what happens at the end. This is an effect. You have less money made, and the cause of that is you have slower rate of reaction. So this is, the cause. I shouldn't be writing slower rate of reaction. This is the cause. So the cause is if you have a slower rate of reaction, and the effect is less money made. So if you have a slower rate of reaction, you'll have less money made. All right, the next thing you have to do is write two sentences using one of the phrases below. These are the two phrases that connect the two statements above. So I'm going to do the first one for you, show you how to do it, and I'm going to let you do the second one. Okay, so I'm going to use this phrase here, results in. So I need to decide, I'm going to put results in that connect the two statements above. And I need to decide, well, which one is going to go before results in and which one's going to go after. So I'm going to put results in the middle, results in. Okay, so what's going to make sense? Slower rate of reaction results in less money made, or less money made results in slower rate of reaction? Okay, well, to me, what makes more sense is if I say slower rate of reaction results in less money made. Does that sentence make sense? Let's examine it. Slower rate of reaction results in less money made. Does a slower rate of reaction result in you having less money at the end? Yes, it does. That sentence makes sense. I'm very quickly going to write it for you the other way around, just to see that it wouldn't make as much sense. Less money made results in slower rate of reaction. That doesn't really make sense. Like, having less money at the end doesn't cause you to have a slower rate of reaction. It's the other way around. So it doesn't make as much sense that way. So hopefully, I hope that you guys can see that. All right, so what I want you to do now is the same way as I've done the first one. I want you to write a second sentence, but you have to use this phrase. Pause the video and do that now. Okay, so hopefully this is what you had. Less money made is a result of a slower rate of reaction. If you had that, well done, good job. Again, that is the only way it makes sense. If you had them the other way around, if you read carefully, it's not going to make sense. Okay, so well done. If you got that right, good job. Okay. All right, let's do some more practice questions. Okay. All right, so I'll pause the video and just do 1, 2, and 3 first for me. Pause the video, do 1, 2, and 3. Okay, so hopefully you should only be watching if you've done 1, 2, and 3. Let's go through the answers now. It says different companies produce at different something of reaction. That's going to be rates of reaction. Good, well done if you got that right. A reminder, you should be writing full sentences. You shouldn't be just writing down the missing word. The whole idea is to get you better at writing sentences, better at writing science. Okay, companies have the same amount of something to produce. Well, you might have put product in there, and that's not necessarily true. Not every company is going to produce the same amount of product. So they don't have the same amount of product to produce. What they do have the same amount of is time, and everybody's got the same amount of time. It's how you use the time that's important. Companies have the same amount of time to produce. Companies who optimize the rate of the reaction can produce something. Okay, well, that's going to be more money or more product. More product, you might say more product, more profits, or more money made. All right, anything there will be okay, any of those. Companies who optimize the rate of reaction can produce more product, can produce more profits, can produce more money, because they're all connected to each other. Right, let's look at the next one. Below are 2 containers showing the amount of vaccination produced by 2 companies over a 12-hour period. That should be a vaccine, not vaccination. Vaccine. Okay, so vaccine. So 2 vaccine companies and are producing a product over a 12-hour period. Which company, A or B, has a faster rate of reaction, and how do you know? Right, pause the video and do 4 and 5 now. Okay, hopefully you said B has a faster rate of reaction. And how do you know? Well, B has more product produced. B has more product produced. They can only do this if they've got a faster rate of reaction, because they're making the same product. Right, I'm pretty sure you'll be able to do number 6, 7, and 8 now. Okay, have a go at those now. Pause the video and have a go at those. Okay, number 6, give one financial advantage. I hope you read that. Give one financial advantage. So that's got to do with money. So you have to be talking about money in this answer. If you didn't do that, have a look at your answer, pause the video and have another go. And look at number 7, one medical advantage. Okay, so pause the video and make sure you have included those. Okay, so one financial advantage of having a faster rate of reaction is you've got more product to sell, so you can make more profits. More profits from more product. Okay, if you've got more product, you can make more profits. So I'm only writing the word more profits. You should have a full sentence that includes the phrase more profits. Okay, so if you produce more products, you can produce more profits. One medical advantage of using a faster rate of reaction. Well, if we take a look at this example, the 2 vaccines, what's a medical advantage of having a faster rate of reaction? Well, more people can be vaccinated. Now, it might not just be a vaccination drug, it might be an anti-cancer drug, for example. But more people can be vaccinated. So that's very topical at the moment, because we have companies racing to try and beat each other and try and make sure that we have enough vaccine. And we're trying to get a vaccine out to like millions and millions of people. And the thing that's slowing us down at the moment is that there's not actually enough vaccine for, Ireland has delays at the moment. We're trying to get enough vaccine for everybody. If we had more of supply of the vaccine, we'd be able to vaccinate people quicker. So if the companies could make it quicker, then we could vaccinate people quicker. So that's obviously a medical advantage. It might not just be vaccines, like I said, it might be anti-cancer drugs. It might be be drugs against diseases like cystic fibrosis, multiple sclerosis, like any disease that has a medication. Well, the medicine's going to be made somewhere using a chemical reaction probably, and a higher rate of reaction is going to mean that there's going to be more product produced, and it can reach more people and help more people, and it can also make more profits for the company. In industry, why is it important for the rate of reaction to be as fast as possible? So this is just summarizing what we've learned so far. It's important for the rate to be as fast as possible so they can produce. You should definitely have the phrase more product in here. And if it's in industry, then industry and businesses are interested in profits. So more money made. Now, again, you should definitely have this as a full sentence. I'm just giving you the key parts that you should have in your answer. All right, so today you have quickly, just to recap, you have learned what is meant by rate of reaction, how fast or how slow a chemical reaction happens at. Chemical reactions involve reactants, the atoms of reactants reassembling to form new products. Reactions can be really fast, like explosions and combustion, and they can be slower, like reactions between like a metal and an acid, magnesium and acid, or something really slow, like your bicycle chain rusting, or any metal rusting is really slow, happens over a long time. We've learned that there is lots of evidence to tell us if a chemical reaction is happening. We can't see this stuff happening. We can't see the atoms rearranging because they're just too small, but we can see evidence at eye level, like light, sound, heat, fizzing, color changes, all evidence of chemical reactions. And lastly, we've learned why chemical reaction is important in industry. Faster chemical reactions allow companies to produce more product, more medicines at a faster speed and make more money for themselves and help more people with their products meet demand of the customers. Okay, so that's it, guys. I hope you enjoyed the introduction to rates of reaction. If you found this easy to follow, do leave us a like. Do leave a comment down below if there's any particular topic you'd like me to tackle for you guys in the future. And I will see you in the next video. Thanks, guys. Bye-bye.